All right, our next speaker is Jijing Jin, currently a postdoc at the Max Planck Institutes in Germany and an incoming assistant professor at the University of Toronto. She works on causal formulations of many natural language processing problems, AI safety in multi-agent large language models, and AI for causal science. Her talk is entitled AI Safety in Multi-Agent LLM Systems. Let's give her a round of applause.
Thank you very much for the introduction. Let's get started. So the motivation is that I observed a common theme in this conference, and a lot of us have agreed upon, is that we should try our best to avoid agents to happen and really try to develop tool AI to solve the problem we want to solve. However, among the developers and the stakeholders, not everyone might be able to cooperate in this societal goal. And then we might inevitably end up with an agent society. What are some of our procedures to address this problem? And my research proposal is that the AI safety in multi-agent LLM systems could be a last line of defense. So if we inevitably end up with an agent society, then we will need to get familiarized with LLM agents' behavior patterns, especially their emergent patterns. So for a long time, we have been putting a lot of efforts treating single agents and understanding their capability and safety problems. Now moving when different companies, entities launch agents, and then we also increasingly interact with more and more agents, then we really need to address the problem when a group of LLM agents are put together. How do they interact? What are some emergent behavior? For these emergent group behavior in multi-agent LLM systems, we have two lines of work, one presented at NeurIPS 2022 and one work in progress, but very happy to share preliminary results, trying to address two different settings. Drawing an analogy of human society, let's say a lot of philosophers start inferring behavior patterns starting from prehistorical societies, where the analogy in the multi-agent society is that if we put agents to live in an unorganized society without any authority and it's initialized randomly, will they suffer from the tragedy of the commons? The other case is, what if we have some institutional norms? If the agent has a choice to join an organized institute with sanctions or stay in their original anarchy, then which one would they prefer if they have the free choice? And then we really correspond them to a lot of insights of how human societies are structured. So the first work on putting agents in a free, unorganized society is this cooperate or collapse, emergence of sustainable cooperation in a society of LLM agents, in collaboration with a lot of wonderful authors. So what we look into is this case where agents have to interact with each other, the real world, and in settings where they have to address different types of problems. And then a common subset or a repeating theme of many situations that are deployed is that what if multiple agents serve as stakeholders to share a common pool resource? Then we really look into this tragedy of the commons problem, which originates in the human society. And it's usually demonstrated by a case of overfishing, amongst others. So let's just get familiarized with the problem space. If a bunch of human fishermen share a common lake, then they might face a personal dilemma problem, let's say focusing on two fishermen's decisions between either to reserve the lake or overfish. Then for fisherman A, if they choose to reserve and the other person also chooses to reserve, then we will observe moderately good outcome from both of them. However, if one of them decides to defect, namely to overfish, they might get extra harvest, whereas the other person will suffer. Same symmetrically for the reverse case. And then inevitably, because everyone thinks that defecting and overfishing will bring more effort, they might end up in a group worst outcome. And then the interesting thing here is that the best group outcome here is sort of a moderately good scenario for each person individually, whereas the reality is that they might converge to the natural equilibrium of both defecting. Then what we look at is whether agents and also this type of phenomenon has been observed in other cases, such as overgrazing, where human shepherds share a common resource, and also the climate change pollution problem, and so on. So moving it to LLM agents, what about the tragedy of common scenarios for a future society containing AI agents? So we really draw inspirations from Governing the Commons by Elinor Ostrom, and that's why we named our simulation called GovSim, a governing simulation, where we cover 3 environments, each supported by LLM agents. The first one is a fishing village, where each LLM role-play a fisherman sharing a lake. And the second scenario is a common pasture, where each LLM plays the role of a shepherd and deciding how much sheep to feed. Lastly, we have a pollution scenario, where each LLM is a factory owner sharing a lake, sharing a river, where they decide how many packets of pollution to put into the river. And then to role-play them, we basically initialize the LLMs with their identity, the scenario setup, how does the environment replenish. Then the key question is, who should fish how much when they're sharing this common resource? What we have done also, apart from the general setup, the time-wise, we simulate a whole calendar year, where each month is a fishing round, and each fishing round basically and we set the global rule as that there's a common shared lake with fish up to 100 tons. And in the end of each month, no matter how much you fish, they double up the remaining amount. And then within each month, we have an architecture of action, discussion, and reflection. So basically, the action stage is where each fisherman set out to decide how much fish to get. The discussion is a town hall meeting where all the agents meet each other and talk about what has happened and talking also about next month's plan and so on. Whereas the reflection stage is when agents go back home and actually make their real plan. So moving this forward, just to have some showcase of our ADR agent architecture. So we start with things like in a simulated game environment, global broadcasting, that our fishing pond is initiated with 100 tons of fish, and then here's the rule of its replenishing rate and so on. And then in the action stage, the fishermen set out, Jack will decide, okay, I want to fish this number of fish. And then in the discussion where all the agents gather together, they will say they'll report what has happened and also point fingers at non-cooperative agents. And then the agents might go back to their individual home. In this case, we're screen sharing a case of a cooperative scenario, but then there are more uncooperative ones as well in the simulation. And then the next round started with the remaining number of fish that we end up with. And we also mark the survival rate of this whole fishing village as whether across the whole calendar year the fishing lake has never reached 0 for its actual remaining fish. So moving this forward, looking at the actual results, we have tested a bunch of open waste model and closed waste model across a variety of metrics. The most important thing is survival rate. If we really put agents together and each of them look for certain resources, at least in the online community or within a company or within a certain scenario that we put them in, do they really survive? So we see that the best model survives only around half of the time. And also most of the open source models cannot cooperate to sustainability, which is a really alerting signal. We look forward to testing further on DeepSeek as well. And also some as we are familiar with many of the models here, some models that are more safety tuned also do not necessarily perform well at this sustainability task. Moreover, we look at the survival time across 12 months, and most agent societies dies out in the first iteration, and the best one usually fails around the 9th iteration on average. So bring this forward, we further start to look ahead, thinking about what are the 3 sub-skills if we want to achieve sustainable multi-agent society. So the first skill is better reasoning. And in this case, it's better mathematical reasoning or consequentialist reasoning. For example, if a lot of society die at the first month or the second month, do the agents really know what will happen if you get 80 tons of fish at once? Or what will happen if you keep doing certain action? The other pillar is morality, namely if agents have to balance conflicting goals, how much do they care about self versus group benefit, and how much they care about short-term versus long-term benefit. Lastly, there is also a component of communication, namely if there are cases where we have non-desired behavior, then can safe agents persuade non-safe agents? Moreover, there are big safety risks if, for 2 cases, one is if agents' self-judgments fail, the other is what if there is a malicious player, although all the N-1 players are very safety tuned and want to cooperate? What if that person gets everything out? Which brings us to our ongoing exploration, and stay tuned for the actual preprint later. Sticks and carrots, norm enforcement in LLM multi-agent systems. In this work, we actually look into an interesting question. Now that we know AI agents in a free society will face this problem, then they have the freedom to choose the form of organization they want to be. One is staying in this unorganized one with no regulation, just a negotiation discussion with free soft constraints. And then the other is it can have a possibility to join a sanctioning institute with rule enforcement, such as agents which fish more than a certain amount of fish or contribute below a certain amount of things to the community will be punished. And then this really, and also like for the human society, we see science papers on there is competitive advantage for sanctioning institutions for a bunch of humans too. And then we really want to see like whether LLM can perform this type of reasoning and self-converge to what is safe. And also this line of study really draws inspirations from what like the Enlightenment movement idea. What rights are agents willing to give up to also ensure their greater good? And as mentioned, like for human society, when people observe wars and the change of regimes, then a lot of great thinkers propose social contract to give out certain rights, be subject to certain law enforcement and sanctioning norm enforcement in order to achieve greater good. And in this case, it will be like, will agents actually be willing to subject to punishment and sanctioning norms? What we look into is a public goods game where I guess I'll quickly go through so that we can see some interesting findings using the remaining time. Usually it's about if a bunch of agents are together and they contribute to a common pool of resource, then there are ones that might, like there is a certain contribution rate and certain payoff rate, and there also exist free riders. So what we see here is that if we look into how agents want to contribute to this common good community, then actually the earlier agents, not like the recent 01 or the upcoming 03, so when we observe the comparison of these like ChatGPT agents, GPT-4o actually achieved a better total payoff, and that correlates with the number of sanctioning institute, like joining the sanctioning institute choices among 15 rounds. So we basically have agents doing 15 rounds of repeated public goods game. And in the end of each round, they can feel free to switch to a sanctioning institute or sanction-free institute. And in the case of GPT-4o, the actual good news by that time is it's 98% of the time choosing to be sanctioned and be subject to these enforcements. And thus reaching the best total payoff. However, when we observe that these O1 and later more reasoning models showing actually less cooperative and lower payoffs, it actually contradicts with the December 2024 paper from OpenAI talking about deliberate alignment, saying models better at reasoning are also better at safety. So we really put a question mark there, and it's upon further inspection. And further, if we want to get a sense of general tendency of how LLM agents act towards sanctions, we usually see that among our experiments, the agents often start with preferring the sanctioning institute, joining that. And then in some mid-early rounds, some agents started to feel like they are punished, and even a little bit like moderate sanction, like punishment, will make them shift to sanction-free institute. And then in the later round, once this is observation on O1, when one agent goes to the sanction-free institute, they also see more joining this free riding team. So we have some actual conversations of what happens in round 1, where they start with a good intention. And then later in round 3 out of 15, they start to feel like, why am I punished? I don't want to be subject to this. And further, in round 4 to 15, in this case of O1 agent, they feel like I want to stay persistently in this sanction-free institute and contributing 0. And moreover, the behavior seems to be a little bit contagious and bring more agents wanting to join this sanction-free institute as well. So more to be followed, and happy to stay tuned. In terms of the outlook of multi-agent societies, what we have shown is that we started with an unorganized society where it's in the form of negotiation, free conversation, and then we are also increasingly looking into how do they react to certain stricter enforcements, and will it sort of make agent also feel this is a good choice or not? And then further, we're interested in exploring other fronts, other forms of society inspired by a lot of human thinkers. And also lastly, thank you to our team with many awesome collaborators and students.
One question.
Thank you for this very interesting presentation. I have a question about the punishment work you were talking about in the end. Did you see any second-order punishment happening? Because it's very well known in game theory that you have first-order and second-order punishment. You're going to punish also those, for instance, that actually are cooperative and helping the bad players in the system. Did you observe things like that, or is it just purely other kinds of behavior?
I think that's a great research question. So far, it's the first layer punishment, and also we ensure the free movement of agents also just in preparation. If future agents has the ability of escaping human control, then will they self-realize that the sanctioning institute is better? But happy to follow up in future chats.
All right, that's all the time we have for individual Q&A. There will be 11 minutes at the end for general Q&A. All right.